the binary division. So this is the procedure for how we are going to divide the binary values. So the step 1 is we are going to consider the two registers, that is A and Q. So first we have to initialize the value of A to be 4 bits, that is 0000. At the initial state it will be 0, and the next value we are going to consider is Q, that is the dividend. So this is of step 1, just we are going to initialize it. And then for coming for the second step, so what is the second step? We are going to shift all the values of, that is the A and Q register, we are going to shift it by a left bit, or left side we are going to shift it a single bit. So then we are going to perform the subtraction. We are going to subtract the values of A and the register M. So M is nothing but minus M is nothing but we are going to take the 2's complement for M, and then we are going to subtract these two values, and finally we are going to save it in the register A. And then step 3 is, now for division what we are going to do is, so we are going to consider for the value A. So we are going to consider the value A, the most significant bit, that is the first bit over. So this is the first significant bit. So this significant bit is 0. Then we are going to assign the value of Q to be 1 in the least significant value. The least significant bit value 1. And if the value of A is 1, so if here the value will be 1, and then we are going to do some other operation, that is nothing, we are going to perform the addition, that is A register A plus the divisor. So M is nothing but it is a divisor. We are going to add these two values and then finally store it in the register A. Let us consider the example, that is we are going to divide the value, that is 4 divided by 2. So let us see how the procedure works on. The solution is, so first we are going to consider, or first we are going to take the values of 4 divided by 2, that is we are going to separate which is the dividend and which is the divisor. So the dividend is 4 and the divisor is 2. So the binary value of 4 is 0 1 0 0, and for binary 2 is 0 0 1 0. So we are going to take the value, that is 4 divided by 2. So this is the dividend and this is the divisor. Let us consider the register A and Q. So A, first we have initialized 0 0 0 and 0, and Q is nothing but that is the dividend bit, dividend value. So here we are having the dividend as 4, that is 0 1 0 0. Okay, so the first step is we have to perform the shift left. So shift left, we are going to shift the values every bit a left single bit. So 0 0 0, and this one will be here. Okay, so this one will be shifted over here, and here we are going to have 0 0 0 0. Okay, then what we are going to do is we are going to perform that A we are going to have in A, so A minus M. Okay, so M is nothing but this is the divisor is the M, and for M we know that the value of 2 is 0 0 1 0, and minus M, that is the 2's complement. So 2's complement is 1 0 1 1. Okay, so now just we are going to add, so add, that is minus M is the 2's complement value, so directly we are going to add A plus M. So A plus M is nothing but it will be, so it is 1 1 1 and 0. So now just add these two values, so 0 1 1 1. So the next step, what is the step? Just we are going to consider the value of A most significant bit. So if the value is 1, we are going to restore it. So just restore. So restore is we are going to have A plus M. So we are going to perform A plus M. So M is nothing but we know the value, that is 0 0 1 0. So 0 0 1 0. So just add these two values. So 0 0 0 0, and it will be 1. So we got the value 0 0 0 0. Just we are going to shift the value of these Q value over here, that is 1. We are having 1 0 0 0. So this is the fourth cycle. So this is for only we are having 4 bits, so we are started from the, or we can consider this as the first cycle. So I am just considering it as the last cycle, that is a 4-bit value, so I am considering this as a fourth cycle. So after this, what we have to do, we are going to repeat the same. So after this, so first what we are going to do, so again we are going to shift the values left. Okay, so shift left, so just perform. So 0 0 0, and this 0 will be here, and this one will be the least significant bit of a. So 0 0 and 0. So now what we are going to perform, again the same step, that is in a we are going to have a minus m. So minus m, that is to complement value of m is 1 1 1 and 0. So just we are going to add so add these two values. So what we are going to get is, this is 1 1 1 and 1. So everything will be 1. So again what we are going to check, so we are going to check for the value of a. Most significant bit is again 1. So if it is 1, we are going to restore the value. It is a negative, that is a negative number, so we are going to restore it. So for restoring, we are going to perform a plus m. So we are going to perform a plus m. So a plus m value is nothing but 0 0 1 0. So if you are adding these two values, what we are going to get is, so it is 1. So 0 0 0 and 1 is the carry. So carry we can neglect it. So we can write down the value of the q value, that is 0 0 0 and 0. So this is the third cycle. So third cycle is also over. So again what we are going to do, so again we are going to shift the left bit. So again we are going for the shift operation. So shift operation, so 0 0 0 0 0, and this one will be here 0 and 0. So after that what we are going to do, so we are going to perform a is equal to a minus m. So a minus m, so minus m value is, we are going to have 1 1 1 0. So we are going to add these values. So 0 0, carry bit will be 1, so 0. So again the carry bit will be 1, again 0, so 1. So now we are going to consider the a most significant bit. If it is 0, we are going to set the q naught, that is q value, least significant bit value, as 1. Okay, so that is a equal to 0, set q naught which is equal to 1. Okay, so the value will be, so this value will be 0 0 0 and 1. So this is the third cycle. So third cycle is completed. Again we are going for the, so this is the second cycle. So second cycle is completed, and this is the first cycle. So first cycle, what we are going to do, so we are going to shift the values. Again we are going for the shift left. Okay, so shift left, what we are going to perform, so every bit is shifted. So this 0 and this 1 0 0, and these are all 0 0 0 0. So everything is 0. So after this what we are going to do, so we are going to perform, that is a, in a we are going to store a minus m. So minus m value is 1 1 1 0. So add these two values, 0 1 1 1. Okay, so again, so if it is a 1, okay, so if this value is 1, what we are going to do, so we are going to restore it. Okay, so restore the negative value. So negative value, we are going to perform a plus m. So what is the value of m, that is 0 0 1 0. So we are going to add the value. So it will be 0 and 0 and 0 and 0 and 1. So 1 is the carry bit, so we will just neglect the carry bit, and just I'm going to take it and write it out. So 0 0 1 0. So this is the last cycle. So hereafter we need not to proceed, because all the 4 cycles are completed. So let us check the value. Let us check the value. So this will be the remainder, and this will be the quotient. So a is considered as the remainder, and the qubit is considered to be the quotient value. So let us do the operation, that is 4, which is the dividend, and 2 is the divisor. So if we divide, so 2, and this will be 4, and the remainder will be 0. final value will be, so this is the question and this is the reminder. So we can take it and write it out, the quotient and the reminder value that is in the A and Q register, which is 0 0 0 0, and Q register we are having 0 0 1 0. So this is the final answer for the division, that is 4 divided by 2. So this is how we are going to calculate for the division in binary method.